Try to close your eyes for just a second and imagine absolute, total nothingness. I mean, no space, no light, no matter, not even time itself. It is a concept that completely defies human logic, right? We literally can't picture it. Yet, from that unimaginable void, absolutely everything you have ever known burst into existence. Welcome to this explainer, where we're going to journey back 13.8 billion years to try and unravel the single greatest mystery of all, the birth of our universe. So, to really get to the bottom of our origins, we have to confront an almost impossible question right out of the gate. What actually existed before time itself began? It's a paradox that stretches the absolute limits of human comprehension. Section 1. Before the beginning. This is the ultimate boundary of our knowledge. If we hit rewind on the expanding universe, tracing it all the way back, we hit a singularity. This is a point of infinite density and temperature where the known laws of physics simply disintegrate. They break down. Now, the legendary physicist Stephen Hawking had this brilliant way of framing this conundrum. By combining general relativity with quantum theory, he proposed that time is actually just another direction. So asking what came before the Big Bang, it's exactly like asking what lies south of the South Pole. The question itself is kind of meaningless because there is simply no before.
As Hawking so elegantly put it, just as humanity eventually figured out the Earth doesn't have an edge you can fall off, modern physics suggests the universe is entirely self-contained. It doesn't need an outside clockmaker. It was born from this unfathomably hot, dense point, completely independent of any external force setting the clock. It simply is.
Which brings us nicely to Section 2, the Big Bang. This is, without a doubt, the most dramatic event in all of history.
Picture this. In a literal fraction of a millisecond, the universe didn't merely explode into some pre-existing room. Space itself erupted. It expanded outward faster than the speed of light. This violently rapid period is what cosmologists call cosmic inflation. And the sheer speed of this creation was dizzying. From the unified forces of the Planck epoch, the universe just underwent this exponential, wild expansion. By the time it was just 1 second old, it was a blistering 18 billion degree primordial soup, forging the very first subatomic particles. Fast forward to minute 3, and nucleosynthesis takes over, literally fusing the very first hydrogen and helium atoms into existence.
To really wrap your mind around that, the universe expanded by a factor of 1,000,000 trillion trillion in less time than it takes you to blink. That's a 1 followed by 27 zeros. This cosmic growth spurt was so aggressive that it essentially froze microscopic quantum jitters in place, turning them into the literal gravitational seeds for every single galaxy that exists today.
Moving to Section 3, the first light. Following all that explosive violence of inflation, the cosmos finally began to exhale. And it started to cool down. But for about 380,000 years, the universe was trapped in this opaque, glowing, super hot fog of plasma. Then came recombination. The cooling atoms finally captured wandering electrons, which cleared the fog and let light travel freely for the very first time. Out of the dark ages that followed, gravity started squeezing gas clouds until nuclear fusion ignited the first massive stars. This flooded the universe with radiation and made it totally transparent. A massive shift we call reionization.
Remember those frozen quantum seeds we mentioned earlier? Well, they became slightly denser pockets of matter. Guided by the invisible hand of dark matter, they slowly pulled together to weave this breathtaking cosmic web. Imagine a vast, glowing scaffolding made of gas, stars, and nascent galaxies spreading across the dark. And this massive cosmic construction site hits very close to home. About 10 billion years ago, our own Milky Way was forged in a violent collision with ancient stellar systems, including a dwarf galaxy called Gaia Enceladus. Out of all that chaos spun the beautiful 200 billion star spiral galaxy that you and I reside in today.
Now, you might be thinking, how do we actually know all this? Well, we know this isn't just a bedtime story because it's backed by profound observational evidence. The redshift of distant galaxies proves space is still stretching out. We can clearly see the abundance of light elements, that massive cosmic web, and most incredibly, the cosmic microwave background. This is the literal, fading afterglow of the Big Bang itself, and it is still echoing through space right now. Section 4, the dark universe. As our modern telescopes peer deeper into the void, we face a pretty humbling realization.
Prepare to have your mind blown a bit. The atoms that make up you, me, the Earth, and all the visible stars in the night sky, they represent merely 5% of the universe. That's it. The rest is dominated by profound, invisible mysteries. 25% is dark matter, and a massive 70% is dark energy.
We are basically caught in the middle of a cosmic tug-of-war deciding our ultimate fate. On one side, you have dark matter, acting as an invisible glue, pulling galaxies together through gravity. Opposing it is dark energy, this phantom repulsive force that is somehow pushing the universe to expand at an ever-accelerating rate.
Scientists are urgently hunting for these elusive forces as we speak. Deep underground, massive experiments are searching for theoretical dark matter particles known as WIMPs. At the exact same time, telescopes are watching distant black holes. Some recent mind-bending studies actually suggest these black holes might harbor dark energy inside them, growing larger as the universe expands.
Which brings us to our final chapter, Section 5, The Ultimate Fate. This accelerating expansion driven by dark energy brings up humanity's most haunting scientific question: how does it all end?
Depending on who wins that tug-of-war, our universe faces a few terrifyingly grand finales. There's the Big Freeze, where we expand forever until the last stars die out, leaving just eternal cold and dark. There's the Big Crunch, where gravity ultimately wins and drags all matter backwards into a suffocating singularity. Or there's the Big Rip, where dark energy grows so violently powerful that it literally shreds apart galaxies, planets, and eventually the very atoms in your body.
But wait, perhaps there is a totally different answer. The ekpyrotic theory proposes a breathtaking alternative. What if the Big Bang wasn't the absolute beginning at all? It might simply be the latest bounce in an eternal, infinite cycle of cosmic death and spectacular rebirth.
Take a second to just sit with this awe-inspiring reality. The majestic structure of billions of galaxies and your very existence was seeded by completely random, microscopic quantum jitters in the first fraction of a millisecond of creation. We are, as Stephen Hawking noted, the direct product of quantum fluctuations.
When you think about it, we are literally the universe experiencing itself. We are a conscious piece of a 13.8 billion-year-old puzzle, finally looking back at its own violent origins. If the entire cosmos could burst from absolute nothingness, what other unimaginable mysteries remain hidden out there in the dark, just waiting to be found? Thank you so much for exploring the awe-inspiring origin of everything with us in this explainer. Keep wondering and keep looking up.